Hey, welcome back to the channel. Today I'm going to show you how RAG, Retrieval Augmented Generation, is being applied to multi-document processing in a really efficient way. Now, when you think about current demands, fast data retrieval across multiple documents is a real challenge. So today, I'll walk you through building a memory-efficient augmented generation system using a vector DB that supports binary quantization for faster and smaller vector storage. We'll also use deepseek R1 LLM, a model known for its powerful reasoning and blazing fast inference. I'm really impressed with it. And on top of that, we'll be using LangGraph to orchestrate both retrieval and generation steps for multi-document pipelines. Before we jump into building it, let me explain what binary quantization actually is and why it gives you faster and more memory-efficient vector handling. So normally, vectors are stored using 32-bit floating points, what's called float 32, which is dense and memory-heavy. For example, each dimension is a full 32-bit number ranging from 0 to 1. But in binary quantization, we simplify that to just 0 or 1. That's it. 1 bit instead of 32. This drastically reduces memory and speeds up vector comparison. You can store way more in RAM, enabling faster search in your RAG pipeline. Let's walk through how the document indexing pipeline looks. You've got PDF documents. Use a PDF directory loader, process the text, embed the content, and store it in your vector DB. When a user sends a prompt, the system sends it to the RAG setup powered by graph orchestration and a document retriever. Then it generates a response using deepseek R1 LLM, all based on information from multiple documents. To simplify, a user asks a question. Documents are embedded using fast embed, stored in Qdrant with binary quantization. Search happens in RAM using binary vectors. Full vectors are retrieved from disk for re-ranking. This is what makes it lightning fast. Now, let's run through the step-by-step setup. Install the required packages: LangGraph, LangChain, Qdrant, Fast Embed, LangChain Sambanova, and PyPDF. Once installed, we import all the libraries needed to get things going. I used Python to handle OS variables and fetch credentials using user data. Then we initialize Fast Embed for embeddings, plug it into the Qdrant vector store, and set up the Sambanova API key. If you don't have that key yet, don't worry, it's easy. Here's how to get your Sambanova API key. Just log into the Sambanova dashboard, head over to the API key section, and generate a new one. You'll find several preview models including deepseek, which offers lightning-fast inference. You can also create and manage agents here. And for Qdrant, if you're using the cloud version, you just spin up a cluster and grab your API URL and key from a dashboard. Super straightforward. Back to the code. Once I created the Qdrant collection and embedded the documents, the system started working as expected. I tested it with a query, how to get into the flow. And the model responded beautifully. It retrieved relevant content, reflected on key ideas like deep focus and removing distractions. Then I asked how to balance assets and liabilities, and the system walked through definitions, principles of double entry accounting, and how equity balances work, all grounded in the document context. Let's run it live now. When the query is passed into the graph, it begins processing and thinking through the context. The deepseek LLM then returns a clear, concise response. For example, the asset and liability question led to a thoughtful answer. Assets must equal the sum of liabilities and equity. Every transaction keeps this balance intact. I really like how accurate and document-grounded the answers are. If you want access to the notebook I used to build this, especially around binary quantization and fast RAG, I'm happy to share it. Just drop a comment below, and I'll get it to you. Thanks again for watching, and I truly appreciate your support.